Who's ready for some more logs? Oh, you, I know it's you and I see it because you can, of course, make it maths. I said here that you can't even have a good slogan without a okay. Gotta give it going, right? So for this one, we're given f of x equals y equals log base 2x. And what I'm excited about today is we're getting back into our visual. So the last two sessions were just algebra, kind of understanding logs, and now we can get back into this visual space. So first thing you're gonna have to do is sketch, and we're gonna work together on this one. Sketch, and generally when you sketch, you're showing all intercepts with the axes, and then we're gonna plot one more point. I've suggested we're gonna choose x being 2, and we'll see what the y value is. Then we're gonna determine the inverse and write it in the form y equals. Okay, so let's go through this. Y equals log base 2 of x. And let's get ourselves a Cartesian plane, right? Always need a lovely Cartesian plane. So let's move to over here, and maybe we can sketch it right here. X and y, right? Drawn a few of these Cartesian planes by now. And you must be hitting pause because I just scribble mine down quickly, and you probably got your ruler out. Do you? Maybe not. Okay, so we've got our graph here, and I'm just going to write it here. We said y equals log base 2 of x, or f of x. Now we have actually sketched this function before, but we didn't call it log before. And I want to start by drawing this function, and then we'll see maybe where it comes from. Feels a bit wrong way around, but you'll see where this is going to go. So we've got a 2 here. Now when we had a 2 for our base, for our exponential, we have an increasing function, right? So it goes up like that. So it increases for the exponential. So we've got a 2 here, we're also going to have an increasing function. So I want to just draw the log graph as if you know what it is, because it is going to be useful to just think log x, what does log base 2x look like? Hey, it looks like this. So it's an increasing function, and maybe let's work out the y-intercept. So for the y-intercept, we're going to go f of 0 equals log base 2 of 0. Now, apart from my head always being in the way, what's the issue with that? Why can't we take the log of 0? Well, we said in our definition of logs that x must be positive. So this clearly doesn't work. There isn't an input of 0. What about the x-intercept? So for the x-intercept, we know that y is 0, so we're going to go log base 2 of x. Now I suggested, while we're getting into logs, let's just write this way around. Log base 2 of x equals 0. Now we should be at this stage comfortable and confident to convert this to an exponential to solve. So we're going, okay, right? This is 2 to the 0 equals x. 2 to the 0 equals x. Oh, but 2 to the 0 is just 1. So x equals 1. So in other words, when x is 1, y is 0. Or when y is 0, x is 1. So we know that we've got this point on our graph, 1, 0. Now, as I said, going through this slowly step by step so that we kind of get a sense of our log graphs as logs by themselves. We said earlier, I said, that this part here means that it's increasing because that's what we had for our exponential. So it's increasing. Must go through this point. We said that we can't take log of 0. In fact, we said we can't take log of a negative number. We must always take log of something positive over here. This must be a positive value. So we can only have positive values. It must be increasing. So we're going to get a sense that our graph must look, let's maybe make that look a little bit nicer. It's going to look like this. Here's our graph of f. It looks like we're going to get closer and closer to x equals 0 but never get there. Indeed we are. So this, we're going to get closer and closer to x equals 0. So, well, I'll keep on mixing these the wrong way around, right? X equals 0 on the y-intercept. So we're never going to input 0, but we're going to get closer and closer to it. It must be increasing because this is a number bigger than 1. And it must go through the point 1, 0, because when we subbed in over here, that's what we saw. We saw that 1, 0 was our x-intercept. So that's what our graph is going to look like. So when I wake up in the fire drill in the middle of the night and go, what does log base 2 of x look like? You're like, oh, it goes this way, right? Was the sleeping in the log the other one? Okay, so, but the point is, you've got a good sense of what log base 2x looks like, or log base 3x, or log base 7x. It's going to be increasing and go through the point 1, 0 with an asymptote at x equals 0. Okay, now what we can do is we can sketch the inverse. Now, before that, I said we wanted one more point. So let's find another point. Let's go for 2. It must be about here. And we're going to find what that is. Okay, so let's just put this in. I'm going to do it over here so we've got it here. So f of 2 equals log base 2 of 2. So you might go, okay, well, you know what? I'm just going to get my beloved calculator up. I need mine up on my side. And we're going to go, okay, log base 2 of 2. I'm going to tell you it must be 1. You might go, how do you know that it's going to be 1? So we've got the point 2, 1. Let's just quickly analyze what's going on here. This is saying that log base 2 of 2 is 1. Let's just check. This means that 2 to the 1 equals 2. Yeah, that makes sense. So that to the that equals that, 2, 1. So 2, 1. So let's just take a pause and see what we got so far here. Let's get it nicely on the screen. If we're given a log graph and we've got a base that is greater than 1, so kind of like not a fraction, not a proper fraction, then it must be increasing. We know that the x values, these values at least that we're taking the log of, must be positive. We therefore know that the basic function of our log graph is going to look like this. So in your sleep, you quickly can draw that. Okay, now let's draw the inverse. So for our inverse, what do we know about inverse functions? Well, we know that what is x is y, what is y is x. And we know that it's a reflection about the line y equals x. So let's do this here. Y equals x. It's going to reflect about that line. Let's show that. And for our inverse, we know that what was y is x, what's x, y. So let's take this point. This is our x-intercept. It's going to become our y-intercept. So we've got 0, 1. We had an asymptote at x equals 0. So therefore, we're going to have an asymptote at y equals 0. We had this point over here, 2, 1. So if we reflect it, it's going to become the point. Oh, let's do it in this lovely color. Let's just get that. And put that there. Okay, so that's the point 1, 2. What was x is y, what is y is x. This was increasing, so our inverse is also going to be increasing. Now this should look like another function we had before. Does it? Do you recognize it? Maybe not. Maybe. Let's find it algebraically. So for our inverse. And with all these scribbles, notice that that's why I try and there's lots going on the page, but hopefully this goes together and we summed it up 1, 0. So inverse we're trying to work out. Remember, what's x is y, what's y is x. So y equals log base 2 of x. But now x equals log base 2 of y. Okay. Now, I don't know how you're feeling yet. I still feel like I just want to rewrite this. So the log's on the left-hand side and we can convert nicely and go, okay, so 2 to the x equals y. 2 to the x equals y. Let's just write it back to the way around again. So y equals 2 to the x. Hey, look at that. That's just the exponential. Indeed, the one we started with. It's 2 to the x. It's increasing. Does that? Oh, that looks like that exponential. Maybe you saw that earlier. Come on. But there we go. So that's our kind of our process. So let's do this with a couple more, and we'll go a little bit more speedily now that we've built up our nice foundation. So we've got f of x equals y equals log base ax. Goes through 4, 2. Determine the value of a, and perhaps the rest of the instructions would be sketch, show all asymptotes, show all intercepts, blah, blah, blah. So let's work this out. So we got y equals log base a to the x. But it goes through this point 4, 2. So how could we work out what a is? Well, if in doubt, let's just substitute and see where that takes us. So y value is 2 log a, boop, a, and x value is 4. Okay, so we need to just solve our equation. The log of what base of 4 is going to give us 2. Maybe let's try and practice doing this, not switching all around each time, and go, okay, so a to the 2 equals 4. So a to the 2 equals 4. What when you square it gives you 4, and there are 2 answers? Well, there are 2 numbers. We could say a equals -2 or a equals 2, right? -2 squared is 4, 2 squared is 4. Why are we not interested in that solution at all, though? Well, a represents our base, and our base is always positive. Remember, we saw that when we had that definition. We said a was always positive, and also a wasn't 1, because that was a bit boring. So, well, better reasoning than that. But so a can't be a -2, so a is 2. Alright, so therefore y equals log 2 to the x. Well, we just sketched that function, which is why we're not going to do it now. Let's go through this. Y equals log base ax, and it goes through 2 minus 1. Determine a, sketch, inverse, blah, blah, blah. So let's do this. Y equals log base a of x goes through this point here. So we know that we've got log base a. Our x value is 2. Our y value is -1. So solve, give it a go. Okay, so a to the -1 equals 2. Now, I'm interested in you solving it. So give this a solve, and then kind of jot down what is your method, is a nice method you've got for this. Well, I'm just going to jump straight to a as a half. Now, wait a second, what? Now, maybe we could look at this, solving this in 2 ways. A to the -1 equals 2, which means 1 over a equals 2. Let's continue with the cheat methods, not cheat methods, but maybe half cheat methods, and then go through the long way that you might solve this. So 1 over a equals 2. I'm going to write 2 as 2 over 1. Now we take the reciprocal of each side. So a over 1 equals 1 over 2. In other words, a equals a half. That's 1 still using a little cheat at the end here, which is kind of what we used here. Other way, a to the -1 equals 2. That means 1 over a equals 2. Multiply both sides by a, like it's the lowest common denominator. And so when we do that, we get 1 equals 2a. Divide both sides by 2. And we get a equals a half. You know what? I'd be tempted to say this third option's preferred, because look, it just followed everything nicely and there wasn't just some giant leap of logic. Okay, so a equals a half. So now what we know is that y equals, or f equals y, log our base is a half of x. Now let's run through this, and I'm going to take you through. So x, y. Cartesian plane ready to go. We've got a base of a half. Increasing or decreasing? Decreasing. X values, our inputs here. What can those x values only be? They can only be positive because we're only taking the log of positive values. So we know we must be in this, or there I can actually do it, this side of the world here. So we're only in the positive x values. We know that this graph is decreasing, so it's going down. Our x-intercept, let's work out. 0 equals log half to the x. Well, a half to the 0 equals x. So again, x is going to be this point here, 1, 0. Let's do it over here, actually. 1, we're close, 0. Okay, it's decreasing. We've still got our asymptote over here at x equals 0. So there's only one way we can draw our graph. It must be going like that. Gets closer over here, goes through that point. Okay, so that's that one. Let's look at our inverse function. So for our inverse, let's start algebraic this time. So for our inverse, for f minus 1, we're going y equals log base or half of x. And I'm saying the one as I write the other. The x's become y's, the y's become x's. Okay, so from here we can go for it and go, well, let's write this as a half to the x equals y. A half to the x equals y. Hey, look, it's an exponential. Is our exponential increasing or decreasing? Well, it's decreasing as well. We know that what was x is y, so this x-intercept is now going to be our y-intercept. So we got 0, 1. We have an asymptote. We had one at x equals 0. So our asymptote is going to be at y equals 0. We know then that this is decreasing, so it must go through here. And let's label that f minus 1. This one here was f. Ooh, let's just get rid of that thing. F. Okay, so there are two functions. Again, we actually drew these two functions before because we already had a half to the x at some stage. We just didn't know that log was the inverse at that stage. So to practice those, exercise 5 just became a favorite friend of yours. And you know what you need to do? Do you know what you need to do? Of course, you need to make it maths. So enjoy the making it maths. Here we go.